Here we are. We're at the end of our chapter. We are now on lesson 1.8, orders of operations. And if you remember from last year, we looked at something called BEDMAS. And BEDMAS means an order of how we should complete our operations, because either algebra has kind of led us into that pattern of how we solve a mathematical sentence or an expression. If we just review what BEDMAS stands for, B stands for brackets or parentheses. So anything that looks with curved brackets or with square brackets or even with curly brackets, I can solve those. And I always solve from inner bracket to outer bracket. So anything that is embedded in the problem, I'll be able to solve first, or I should solve those first, and then move to the outside brackets afterwards. Now, within the bracket, there will be some other operations in there, and I follow BEDMAS all over again. So I can have multiple BEDMASes within the same problem within, let's say, a bracket, and then I'll complete all the stuff in there, and then move on to other brackets as well and solve stuff in there, and then combine things at the very end. I also have E, which stands for exponents. It also stands for roots. We kind of neglect the R in BEDMAS. We could call it BIRDMAS to include the roots a little bit. So exponents, again, we move from left to right, so we always start from left to right, but we always solve everything with an exponent first. So which example, 2 to the 4th power, I would solve that before I add it to anything else in this problem. So in this case, for example, like solve this exponent first, so 2 to the 4th, before I do any addition or even the multiplication. The next one is the division multiplication family. And the way I solve this is always from left to right. So even if a multiplication comes first, I mean, if it shows up on the left first, then you solve the multiplication on the left first, even though it looks like BED, the D and the M, the D look like it comes first. But they're in the same family, so whichever one of these two shows up first, i.e. on the left, you'll solve that one first. Also, the final two operations, and these are both in the same family as well, are addition and subtraction. So whichever one comes first from left to right. Now, just a point while I'm writing this down, note that this always comes last. So that gives you a mental kind of wall within this problem. So if I see 2 to the 4th plus 3 times 6, in my head I see addition and subtraction come last. And because that comes last, I can separate this problem into two halves and even solve them separately and then combine it at the very end. So I can work on those at the same time. So I'm going to write down 3 examples here, and you can pause the video and then you can take some time to solve them, and then we'll go over the answers together. So here's the first example. So this is example A. So the example is 2 squared plus the square root of bracket 8 squared minus 2 times 10 close bracket over 11. So that's the first example. Try that one out, press pause, and then we'll solve this one together. Once you've solved this problem, we can see, just as we looked before, this positive sign, since we see this plus sign right here, that could be a clear division. So we can actually separate this into 2 problems, solve them separately, and then combine them at the end with the addition. What I'll do is I'll look for what this really big square root side does. Is a big square root acts like a bracket, so which means everything has to be done within the square root before I actually do the square root. So this acts like a bracket because it holds it in. So let's solve this first. So 2 squared I can solve as 4, and then I can solve the rest of the inside. So square root, and I see a bracket at the top, so I will solve whatever's in the bracket first. So that means 8 squared minus 2 times 10. Again, I solve according to BEDMAS what's in the bracket, exponents are next. So I have 64 is the same as 8 squared minus 2 times 10. If I'm a little bit on my expert level, I would see that a minus sign is last, so then I'll work on the multiplication and I'll do minus 20. But let me just add an extra step just so that we can look at it. So now I still have my 4 that's still hanging out there. My square root is still there. Now I work on the inside of my bracket and I have subtraction and I have a multiplication. Well, I move down my list and I have division and multiplication comes next. Now notice this big division sign. Now when does that come in? Again, a division sign, a large division sign or the fraction sign also acts like a bracket, which means that everything around or above that has to be solved first before I do this division over the 11. So I solve everything above it first. So everything on top, I do 64 and then now this minus 20 divided by 11. 4 plus. I still continue to solve the top of this fraction. 64 minus 20 is 44 over 11. Now I have this division here. Even though I did the subtraction was kind of in a bracket still. It was still on the top, so it still acted like it was in this bracket on the top. 44 divided by 11 is 4, so I solved that division. And now I can go back to this bracket, to the square root that acted like a bracket. So I have 4 plus the square root of 4 is 2, and then 4 plus 2 is 6. So I was able to solve that one pretty well. Let's just take a look at a couple other examples. So let me just erase the screen. If you lost it, you can just press rewind and you can go back. Letter B, so this is another example. I have 3 curly bracket, 2 square bracket, then parentheses, 5 plus 3, close bracket, squared, divided by, open parentheses, 10 minus 7 plus 1, close parentheses, close bracket, square bracket, close curly bracket. Wow, what a tough question. I'll let you try this one. Press pause and see if you can solve this one. I can tell you there's approximately 6 steps that you can solve this problem altogether and see if you get the same answer as me. So once we continue on, again, we look at brackets and we start from the innermost bracket first. So I see 2 inner brackets. I see this one and I see this one. Because I'm separated by a division sign, I can work on them at the same time. So let me just underline what I'm going to be working on next. So I'm actually going to work on this at the same time now. If you want to separate them and rewrite them in 2 different lines, by all means, take an extra line and do that if it's more comfortable for you. So 5 plus 3 is 8. My squared is still there. Now I'm working on this bracket. Now, I look at my operations, I have a subtraction and an addition. Normally in BEDMAS, A comes before S, but because they're in the same family, I work from left to right. So 10 minus 7 is 3 plus 1. I still have my square bracket and my curly bracket. 3, curly bracket, 2, square bracket. And I'm now still working on these separately because of this division. And so I have 8 squared. There are no more operations in this bracket, so I can drop these parentheses and change 8 to just 8 squared, and this becomes 64. Divided by 3 plus 1 becomes 4. It was in parentheses, but in the next line you can see I'll just drop that, because when there's no operations, you can just drop the brackets. 3 bracket 2 bracket 64 divided by 4. If I do that, is 16. I cheated a little bit there. And now this bracket's gone, so now I'm left with this and that. Now let's look at this. Remember when we looked at algebra last year, we saw a number and then a variable, or a number and then a number right away, or a number and a bracket. If this is the case, if I have a number right beside the bracket, this acts like a multiplication. Because just like in algebra, if you had 3a, it really means 3 times a. So I start with my inner bracket first, so that means that 2 times 16. So my 3 curly bracket 2 times 16 is 32. Close my curly bracket, 3 times 32 is 96. Okay, one last example, and then you can keep trying more for yourself. This one's a little bit tricky. I have 2.2 in brackets cubed, which means to the 3rd power, Then I have a square root sign, and then I have 5 times 1.2 minus 17 divided by 4 equals what? So take some time to pause the video so you can solve this one first. Now, once you've unpaused the video, so let's take a look at how we solve this. Now, we see the square root. It acts like a bracket again. I have this 2.2 to the third power, and then I have nothing in between this 2.2 to the third power and the square root. So just like in here, because there's nothing in between, this acts like a multiplication in between these two. So because it acts like a multiplication, I can work on these two parts separately. But, so let's start with brackets. I don't have any operations in this bracket. This acts like a giant bracket, so I can work on this as well because it's a giant root. As well, I have an exponent in there, so I can work on my exponents and roots at the same time because it comes ahead of a multiplication. So let's just start with just this exponent, 2.2 to the third power. I might need my calculator a little bit, and I find out that my answer is 10.648. I'll leave it in brackets just for clarity, just so that we know that this is a whole entity on its own. And I'll just rewrite everything on this side just so that we can see what to do next. So because I have no signs in between this number and the square root sign, it will act like a multiplication. This means I have to leave this until I do my root first. Roots always come first before this multiplication. So I'm going to rewrite this 10.648 again, and now I'm going to solve everything that's in my root. I have some operations in here. I have a multiplication, subtraction, and division. So my subtraction is always last with addition, so I can work on this part, the 5 times 1.2, and my 17 divided by 4 in the same step. 5 times 1.2 is 6, and 17 divided by 4 is 4.25. Notice I did both of these in the same step. The reason why I could is because it's separated by a subtraction sign. Subtraction and addition are always last. So now let me continue on this problem. So my 10.648 is still there because my root still has to be solved. And now I do the subtraction within this root because the root acts like a bracket. So 6 minus 4.25 is 1.75. And now I solve my root. And I'm going to put a little approximate sign because I'm going to do some rounding here. Because the square root of 1.75 is approximately 1.323. So using my calculator, I found the square root of 1.75. And that's approximately again. So now I have an approximation. Because I rounded off my numbers, I can't be exactly equal. I'm around it. And now I have my multiplication that's very last. I'm just going to draw in a little multiplication there, multiply the two of these together, and my answer is 14.09, approximately. So if you're off by a couple of decimals, that's okay. So this concludes our entire chapter on orders of operation and on chapter 1. What I want you to do is just take a look at and reflect about this and whether or not your calculator does the same steps or what in the same order, or whether or not you have to type them in differently in your calculator. Then once you do that, then you can see how your calculator actually works when using square roots or when using brackets or when using powers, because there's a lot of buttons now that you're going to have to get used to on your calculator. So we have a lot of practice questions to do in class. We're done the entire chapter, so we'll have a unit test coming up. But if you have any questions, don't be afraid to ask. Hope you understood this lesson.